time in the future we could, learn how to harvest the energy from this super fundamental level. How we now we are able to harvest this energy from nuclear level, where we from nuclear fission and fusion. But maybe someday we will be able to do that with quarks also, and there the energy density is even higher than in nuclear energy. So potentially, it's of course a very very important field of study, I guess. But again, it's at this point it's very, very theoretical.
Okay, thank you. I mean, we're just sorting out a couple of things with Facebook here.
Okay.
But yeah, thank you for your CV. I'm sorry to ask.
Yeah, okay. You're welcome.
Okay.
Yeah, okay. You're welcome.
We'll have to turn that down, otherwise we're going to... That's how much time delay we got. Oh, Sharon said hello anyway, that's good. Right, I think we might as well get underway, even though there's not many of us here. We are going out to the world. Well, I'd like to welcome everyone to our first Sunday of the month global get-together, which we are now holding. First of all, I'd like to send out lots of love and best wishes to David Talbot, who unfortunately suffered a stroke a little while ago. He spent a week in hospital, 3 weeks in recovery, and spent most of the time in the wheelchair. He's regaining his steps slow and gets more with every PT session. And I'm sure we'd all love to, send him all our best wishes. And we want to see you up there sometime soon. Where we got Eugene at the moment, coming in from Belarus. Anyway, get well, Dave. Yeah, well, we're running a bit behind. That's okay. In this run up to Christmas and these Sunday evening gets-togethers, we are very much testing the waters with the technologies and adding new bits to it, like a live guest coming in with us. And this is very much a base level to inform people of the electric universe paradigm and the shift in science which is now happening. It's been going for 10-15 years. But within the last year or so, it's really picked up, and this is mainly because of something called the Sapphire Project, which stands for Stellar Atmospheric Function in Regulation Experiment, and we'll be looking a little bit at that later. We are also doing this as a preliminary to put together a curriculum, because we are very much going to be carrying on from the ideals of the Facebook group, the Electric Cosmology Facebook group, and taking this education, this idea of educating people to a bigger format. I met with Rob and Pierce, who'll be joining us later, and we decided that we would pool our resources and take it a bit further. Now, with the help of some of the people within the Facebook group, this has just speeded the whole thing along with our good friend She and Sharon, who are more than happy to sort of like put their enthusiasm into this of what we're trying to achieve. And this will be going up to the higher level, but like I said, I'll let Piers tell you about that later. Anyway, I think I want to introduce our guest, Eugene. Hello, Eugene. How are you? Hello, Eugene. Oh, hold on a sec. Why can't I hear you? Yes, Eugene. Hello, Eugene. How are you? That's not the one I want to hear. That's the one I want to hear.
Yeah, sorry, my microphone was muted.
That's okay. Hello, Eugene.
Hello.
Welcome to Facebook and the world. And And can you want to tell everybody about yourself and who you are and your history?
Okay. So my name is Eugene. I am a researcher at the National Academy of Sciences of Belarus, one of the institutes of the National Academy of Sciences, in particular the Institute for Power and Nuclear Research. So I work there as a researcher, and I also do my PhD thesis there, and it is about the physics of elementary particles, essentially the physics of quarks. So quarks are supposedly the particles that make up the protons, neutrons, and many other particles called hadrons. So in this field we apply, and by we I mean myself and my scientific supervisor, we apply a sort of original approach where we take methods that are usually used in quantum information theory and apply them elsewhere, namely here in the elementary particle physics. So basically it's kind of a fundamental research that I'm doing. But recently, like a few years ago, I stumbled upon the Electric Universe people, namely the Thunderbolts YouTube channel, and I really liked the stuff that they did, and I contacted Walt Thornhill and said, hey, I have some experience, in like modeling and stuff, so maybe you need some work to be done in this regard. And he eventually sent me to Dave Talbot, who later invited me at the EU conferences in the United States. So I went there, gave a couple of talks, met a bunch of really great people. Well, most of them I was already kind of familiar with through their videos at their YouTube channel. So it was a great experience, and I love being a part of this community. And it's also great to participate in this British part of the EU community. So thank you for inviting me today.
Absolute pleasure, Eugene, as always. Absolute pleasure. Right, so I think we're going to have Rob say a little bit now, just about welcome and what he aims to do in the future. So
okay.
The education side and your toys.
So, very briefly, my name's Rob Shaw. I met Phil at the EU conference that was in Bath, held earlier this year. We agreed that we'd try and put on monthly events in London. We're trying to do a mixed event, people in the room and people online. And we're just hoping to see what happens when people get together. I had a fantastic time at the conference in Bath. It's nice to hear Eugene having met people, deepening those relationships when he was in the States. And I guess from my point of view there isn't a specific agenda with this other than just to get people together and see what happens. We have got more of an agenda when it comes to education going forward. As Phil's already mentioned with peers, we're looking at drawing up an Electric Universe curriculum. I've experience in education, Piers has obviously got experience in education. We're going to pool our resources and put together what we're labelling at the moment an Electronic Cosmology curriculum. That being trying to contrast that cosmology with the atoms in the vacuum, the mechanistic model. In that regard, on Tuesday I'm meeting a man called Professor Frank James from the Royal Institute here in London. He's a world-renowned expert on Faraday, and the idea is that we're going to talk to him about the controversies that Faraday experienced trying to describe electromagnetism as lines of force and not as atoms in a vacuum. That caused him considerable stress, I'd say, in his life. Trying to break through that, break down the old paradigm is a theme I think we're all familiar with. Faraday was working in the mid-19th century, and he in his time had to battle with what you might call the scientific forces of conservatism. So the next event we're running with any luck, will be, the theme is going to be different instances of scientists coming up against the what we could broadly call the forces of conservatism within science. Not evidence-based argument, but argument that relates to tradition. We've always done, we've always done it this way. Why should anything change? I think is an argument we're all familiar with, and it's not a scientific argument. So the 4th of December will be themed around that. Hopefully Jeremy Dunning-Davis will be able to update us about what's happened since he predicted at the Bath conference that the death of Stephen Hawking would have an effect on certain bits of astroscience. There's Richard Feynman. It's my turn to get off the stage, I think. I'm not going to compete with Richard Feynman. Yeah, so going forward, the next event will be about the forces of conservatism in science, if you like, and talking about 2 or 3 examples of very famous, very successful scientists who hit the buffers in terms of let's call it the social aspect of science, which can be very conformist. And yeah, I didn't know I was talking, but there you go. That's my little 2 pennies worth. Hello, Facebook.
Excellent, thank you, Rob. Okay, well, tonight we're going to be dealing with the fundamental, which is basically the sun. We've got millions and billions of stars out there. We've got millions and billions of galaxies with millions and billions of stars within them. And so it is quite a major part of how our universe works, really. So we're going to start by looking at stars, how they work electrically rather than mechanically. Yeah, then we'll be asking Eugene to join us and add his insights into why we should be looking at an electric model rather than the burning gas form model. So
now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it.
All right, Steve, come on.
Then we don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compared to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is, it doesn't make a difference how smart you are who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
Yeah, so could you hear that, Eugene? So,
yeah.
You could hear that okay?
Well, not okay, but I heard something, yeah.
Did you know what he was saying, basically? The fact that...
yeah, that the empirical method, basically, if your theory is not consistent with the experiment, then your theory is wrong. That's what I understood.
Yeah, and the fact that they guess first, which is rather a weird way of going about stuff, I would have thought. Yeah, because obviously in the electric universe we sort of go for observation and experimentation, whereas the mainstream very much guess first, and that's what Feynman was saying, that it doesn't matter how beautiful your guess is, how clever you are, what your name is, if the guess doesn't express what reality tells you, then the guess is wrong. Simple as that. And of course the mainstream have been ignoring that advice for the last 50 odd years or so, and we are now finding out that the guesswork is wrong. So we're gonna do a couple of video clips here. It's one by Dr. Robitaille and one by the Thunderbolts Project, to give an electrical explanation of why stars arc. They don't burn, they arc, and what the suns are actually made of. Not a gas. A gas would normally expand into a vacuum, although space is not a complete vacuum, it's a very weak plasma. it's still under gravitational rules, should expand into the vacuum and so not hold together at all. But anyway, let's have a look at these video clips, and yeah, and we'll see what the experts have to say. Unfortunately, we have to listen. Let's see, have there we go.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In part 1 of this presentation, physicist Walt Thornhill began laying the foundations for a new theoretical understanding of our Sun and all stars. Standard theory remains that stars are born due to the gravitational collapse of material in nebular clouds over vast spans of time. We're told that stars die when they inevitably exhaust their fuel, or simply explode. But for many years, countless discoveries have contradicted these fundamental concepts. In this episode, Thornhill further explores the electric universe predictions and explanations for a variety of stellar phenomena.
So let's return to the declaration of our esteemed internet lecturer that our Sun was born about 5 billion years ago. There is no evidence whatsoever for this categorical statement. With the thermonuclear model discredited by the observational evidence, the complex life story of stars is exposed as fiction. 2 recent reports support this judgment out of a countless number of others expressing surprise at unexpected discoveries. On March 6th, phys.org headlined a report, "Star Clusters Discovery Could Upset the Astronomical Apple Cart." It begins, "The discovery of young stars in old clusters could send scientists back to the drawing board, because models of stellar evolution are based on the assumption that stars within star clusters formed from the same material at roughly the same time. However, back to the drawing board always means embroidering the set of beliefs permanently inscribed on the board. No physicist shows the intellectual integrity to wipe the board clean of its unscientific Big Bang myth and start afresh. It's all too hard and scary." So Dr. Kenji Becky from the International Centre for Radio Astronomy Research says, "The formation of these younger stars could have been fueled by gas entering the clusters from interstellar space. However, observations showed that there was no correlation between interstellar hydrogen gas and the location of the clusters we were studying. We believe the younger stars have actually been created out of the matter ejected from older stars as they die, which means we have discovered multiple generations of stars belonging to the same cluster." The words "we believe" are accurate. The discovery of multiple generations of stars is not. The notion of the age of a star is based on plotting a point on the Hertzsprung-Russell diagram where the star leaves the main sequence after the exhaustion of its main fuel. But we have shown that stars do not exhaust their fuel any more than an electric light does. Stars don't die because their fuel runs out or mysteriously explodes. The Hertzsprung-Russell diagram is simply a plot of points and not an evolutionary sequence. Stars have been observed to change swiftly and inexplicably from one location to another on the diagram. When viewed correctly as a mirror image, the diagram represents the change in colour and brightness of a star as the electrical energy focused on it increases along the x-axis. Sharp discontinuities exist in experimental gas discharges between dark mode, glow mode, and arc mode. These discontinuities simply explain the sharply different appearances of faint white dwarfs, bright sun-like stars, and red so-called dwarfs, and red giant stars. The red colour is due to an extensive anode glow, and the faint white colour is simply a coronal glow of a normally constituted stellar body lacking a bright arc mode photosphere. No imaginary ultra-dense dwarf object is required. There is no need to invent an ad hoc requirement for stars to have exploded and then somehow gather their widely scattering dust gravitationally to give birth to younger stars in the cluster. Stellar explosions are often invoked to clear dust and gas from star clusters. Astronomers can't have it both ways, but critically, none of this complicated ad hocery fits the observations of filamentary star birth inside molecular clouds. The second report appeared on May 18th last year in phys.org, titled Stellar Mystery Deepens. A Monash University-led research team made an unexpected discovery that a large group of stars are dying prematurely, challenging our accepted view of stellar evolution. Their results revealed that large numbers of helium-burning stars are dying prematurely in the M4 globular cluster. Professor Latanzio from the Max Planck Institute for Astrophysics said, "Globular clusters are some of the oldest objects in the universe. Although we have some ideas for what is going on in them, every time we look carefully we find something unexpected. They are both fascinating and frustrating at the same time." The international team found that about half of the stars tend to skip the red giant phase, instead becoming white dwarfs millions of years ahead of schedule. Demonstrating once again what's wrong with the modern scientific method, characterized as shut up and simulate, Professor Latanzio continued, "Computer simulations do not agree with this observation. So, as well as continuing observations, new computer models will need to be generated to better understand what is taking place in the cores of these stars. But the computer models are built on missing or invalid concepts. There's nothing going on in the cores of stars, and globular clusters are not understood. So the mathematical computer simulations produce a virtual, unreal cosmos that, like the movies, can be programmed to produce anything you can imagine. And the artist's impressions we see in science reports are little more than glossy advertising material, but much more deceptive because it is falsely labelled real science. There is no real mystery here. With no nuclear fire inside, stars don't die by bloating to a red giant and collapsing to a white dwarf as their fire goes out. The life and death stories of stars are fictional. The bloated appearance of red giants is not due to internal pressure caused by hypothetical helium burning at 100 million degrees in the core of a star. It is a purely electrical effect, witnessed in laboratory low-pressure gas discharge tubes. Red stars are those that satisfy their need for electrons from the surrounding plasma by expanding the surface area over which they collect electrons by growing a large plasma sheath that becomes the effective anode in space. The growth process is self-limiting because as the sheath expands, its electric field grows stronger. Electrons caught up in the field are accelerated until they become energetic enough to excite neutral particles they chance to collide with, and the huge sheath becomes a uniform red anode glow. It becomes a red giant star. The electric field driving this process will also give rise to a massive flow of positive ions away from the star, or in more conventional terms, a prodigious stellar wind. Such loss of matter is a characteristic feature of red giants. Standard stellar theory is at a loss to explain this since the star is said to be too cold to boil off a stellar wind. Arthur Eddington himself expressed his puzzlement about white dwarfs. Strange objects which persist in showing a type of spectrum entirely out of keeping with their luminosity may ultimately teach us more than a host which radiates according to rule. He was right. A white dwarf appears extremely hot, white and underluminous because it is a faint white coronal discharge. As usual, a thin plasma sheath will be formed between the plasma of the star and the plasma of space. The electric field across the plasma sheath is capable of accelerating electrons to generate ultraviolet light and X-rays when they hit atoms in the atmosphere. And the power dissipated is capable of raising the temperature of a thin plasma layer to tens of thousands of degrees. The spectral lines are broadened, sometimes to the point of disappearance, due to the coronal electric field. This gives the misleading impression that hydrogen, whose spectral lines are smeared the most, is missing in many of these stars, and that therefore they are remnants of larger stars that have conventionally lost or burned their hydrogen fuel. So, globular clusters are not some of the oldest objects in the universe. Their spherical shape of a dense collection of stars and their elliptical orbits about the galactic centre hint at a quasar-style birth process from the plasmoid at the heart of the galaxy. If so, the electromagnetic environment inside the globular cluster is different to that in open clusters of stars, so we should expect an unusual distribution of white dwarfs and red giant stars. And the puzzling observation that some globular cluster stars have 100 times more iron than others could also be explained by electromagnetic sorting of elements within the globular cluster at its birth. The fact we don't understand stars in the 21st century highlights what Arthur Koestler wrote in The Sleepwalkers. The history of cosmic theories in particular may without exaggeration be called a history of collective obsessions and controlled schizophrenia. And the manner in which some of the most important individual discoveries were arrived at reminds one more of a sleepwalker's performance than an electronic brain's. Science is still in its childhood, and we behave as infants. We give far too much credit to scientists for knowing what they are talking about.
So, Eugene, I take it, yeah, you very much agree with what Wal was saying there. You know, the fact that we must take and make an electrical, the stars are electrical and can't possibly be burning balls of gas.
Yeah, I would certainly say that there's lots of evidence for stars being actually condensed matter, as Robitaille says, rather than, you know, balls of gas. I mean, his paper, I've actually studied them quite thoroughly, and I really enjoyed the paper of his that is called, like, 40 lines of evidence for condensed matter sun, where he literally accumulated 40 arguments. I mean, just can you imagine the amount of work that was put into this? And I really find many of these points compelling. So for the most part, I would say that, yeah, probably sun is liquid other than gaseous.
I mean, it would. I mean, gravity could not hold a gas ball together, could it, really?
Well, theoretically, I think it can, but but there are other points which are very poorly explained by gaseous models. I mean, for example, the density of the photosphere that is supposed in gaseous models is very, very low. It's like 10 to the minus 7th of grams per centimeter cubed or something like that. So it's like a vacuum, basically. It's not even there, you know.
Yeah, but
it's just or for example, the existence of, you know, these transverse acoustic waves on the surface of the sun that one can see, for example, during the solar flares. The solar flare kind of excites the surface of the sun, and there you can see ripples coming from this place in all directions, and it seems to me like almost, you know, like a surface of water where if you throw a rock there or something like that,
you're going to get the ripples off it.
Yeah, which is again the evidence that it's probably a liquid rather than gas.
And well, I think at that point we'll now watch Robitaille's video, and where he actually explains that in a lot more detail. We'll come back to you afterwards.
Yeah, okay.
Hello everyone, and welcome to Sky Scholar. Today we are discussing black holes. To start, they aren't science. A scientific theory is falsifiable. That is to say, when you test a hypothesis, you must be able to get back the answer that the hypothesis is wrong. For example, if someone has a hypothesis that a certain plant leaf will cure cancer, then that leaf could be administered to cancer patients to determine whether or not the claim was true or false. An example of a non-falsifiable hypothesis is the existence of God. Can there be a scientific test that we can do in the laboratory to prove that there is no God? Of course not. That is why the existence of God is a concept of faith, not science. Many great men believe in God, but the existence of God cannot be tested as either true or false. The pantheon of astrophysics is headed by black holes. There is no observation that I could devise that would make an astronomer conclude that there are no black holes. If an object moves around a point that can't be seen, then there must be a black hole. Or, if there is a bright object that pulls nearby a star, then also there must be a black hole. There is nothing that could lead an astronomer to believe that there are no black holes. To them, it is a matter of faith. Black holes are based on the standard solar model, which is simply incorrect. As I have shown many times in videos to date, our sun vibrates as condensed matter, emits light as condensed matter, rotates as condensed matter, and contains surface waves that act as condensed matter. In fact, every single aspect of the sun can be explained easily in a single step with condensed matter. None of the mathematical or mental gymnastics of the standard solar model are necessary. Black holes are said to form when stars of 20 solar masses or more run out of energy. The radiation pressure required for hydrostatic equilibrium disappears, and the star collapses into a black hole. The entire notion is unreasonable. Radiation pressure does not exist in the interior of gaseous stars, since objects never radiate internally. Laboratory science shows that internal thermal equilibrium is maintained by conduction and convection, not radiation. If stars are made of condensed matter, a term for liquids and solids, then they would never collapse. James Jeans admitted this nearly 100 years ago. Mathematical analysis shows that if the center of a star is either liquid or partially so, there is no danger of collapse, that the liquid center provides so firm a basis for a star as to render the collapse impossible. It is only because astronomers treat the stars as ideal gases that they are permitted to collapse. Liquids and solids are essentially incompressible by definition, and that is why actual stars never collapse to make black holes. Such objects are completely fictional. Speaking of fiction, we come to black hole mathematics, starting with the fact that black hole specific heat capacity is negative. This means that as heat energy enters a black hole, its temperature decreases, not increases. There is no basis for negative heat capacity in such objects, and this points to fundamental problems with these theories. Next, black hole thermodynamics. The Hawking temperature of a black hole is said to be inversely related to its mass. Since when did the temperature of an object, an intensive property, become related to its mass, an extensive property? Another idea in black hole thermodynamics is that the entropy of a black hole is equal to several constants times the area of the event horizon. What's the problem with these equations? The presence of the universal constant of gravitation, g. Nowhere in thermodynamics does this constant play any role. More importantly, the universal gravitational constant is a Newtonian idea which depends on the presence of two masses. A black hole is a single object, not two, and relativistic, not Newtonian. The use of the gravitational constant was inappropriate in both respects. It cannot be used to define entropy or temperature in a single mass. There has been many assaults against the second law in recent years, as documented in this book, and astronomers are responsible for many of them. If you want to learn more about the mathematical problems of black holes, start with this paper by Stephen Crothers, who outlines the problem with using Newtonian concepts in relativity and much more. The consequences of black hole science are serious. It wastes tremendous amounts of public money to particle accelerators and detectors to the tune of billions of dollars. Black hole proponents have also given birth to an equally bad train of thought in dark matter and dark energy, which supposedly makes up 95% of the universe. This points to the fact that astrophysics is currently dying as a science and moving away from real progress into mysticism. It needs a complete overhaul. As I have shown before, we don't understand our own sun properly, which is just 8 light minutes away, but cosmologists think that with weak signals originating from billions of light years away, they can justify new ideas in thermodynamics which overturn much of known earthly physics. None of these ideas are testable. An interesting book on the subject is Bankrupting Physics by Alexander Unziker. I hope that you liked this video on black holes and that it caused you to think about the state of modern astronomy. Please leave a like and subscribe if you want to journey with me through space.
Thank you, Mr. Rabataille.
Yeah, so Pierce has joined us, which is really nice. And so very much with electric weather, obviously it comes from the sun. I take it you are very much against the traditional gas model as well.
Well, the gas model's got problems. I used to do research and wrote papers on galaxy formation. and the mean matter density of the universe. And they worked with Professor Tom Kibble on the black lines, if you like, in space, which were
Black lines?
black lines. Well, that wasn't what he called them, but cosmic strings. But they were a different idea from, they came from the early universe ideas. So they were involving supermassive things. However, they weren't formed by condensation or attraction. Now, I think, you see, I agree with the general view that black holes are probably very difficult to form. I don't agree with him, Robital, saying, well, big G shouldn't appear or something, because, look, I mean, if you do these calculations based on assuming it's always a perfect gas or some sort of gas, then...
Or G's a constant.
Yeah, or G's a constant, then you will get big G turning in there. So big G appearing in these equations doesn't prove that they're wrong or right. I don't know why he makes that point.
Because he says it because of one is Newtonian and one is relative.
Yeah, but that doesn't matter. I mean,
no. What do you reckon?
It doesn't matter. It doesn't have to be. You can still apply Newtonian mechanics to fast-moving bodies. You know, you just have to know what you're doing. But these aren't fast-moving bodies; they're static bodies in supermassive. So it doesn't mean that you can't apply Newtonian mechanics, because you're far enough away from something, certainly it's got a mass and it will operate under gravity. It doesn't mean we understand gravity, but it will, you know, Newton's inverse square law will apply.
Eugene, can you hear this?
Yeah, for the most part.
Did you agree with what Pierre said?
Well, I don't know, actually. I mean, I have very big problems with, you know, cosmology usually, because there is very little, you know, actual observable data present. Basically, all we're doing is, you know, working with different models, and we can't actually do any experiment there. We only have so much, you know, on the observational side. So it's really hard to tell what is what here. And basically, what we have is optics, essentially, and that's it. And
I think we all agree that we are talking about condensed matter. We are talking about a liquid or the solid, aren't we? I mean, we can't really imagine that stars are gas, burning balls of gas.
Well, if you've got a high enough temperature and then the material is above its triple point, then the gas and liquid become the same thing. They're just extremely massive, extremely dense. So to describe it as a gas or a liquid, I don't think it's hyper dense. Doesn't really matter.
Well, but if we're seeing those ripples with the fallback.
Well, that is something else.
I mean, also, if you look at a mass coronal direction, it doesn't look like gas. It looks like a solid rope of matter.
If you're on an astrophysics course and ask what is the surface of the sun, you don't get a very clear answer. I did I got the MSc in astrophysics from Queen Mary College, and things like that were skated over. Suddenly you get from this, which looks like a surface, into a very, very, very low density, super hot corona. I mean, that is well, they just say it's not understood. And then they come into things like, they have this sort of merging of magnetic fields which suddenly release energy, but that is just nonsense.
No, I don't know anywhere in electrical mechanics which says that is a thing that happens. It's there's something that's been invented purely to try and explain their model, which
yeah. There's a lot of invention going on there. Yeah. But I agree with Eugene's point. There's actually a lack of data, observational data, and you have suppositions, mathematical suppositions about explaining galaxy location and whatever. Yeah. And if you accept that there's a lot of plasma around, then of course you realise you've got to use things involving magnetism and electricity a lot more when you have gravity, so you can get rid of the need for dark matter in the centre of the galaxy, for example.
Yeah. Oh, absolutely. I mean, dark matter obviously was just an invention to try and prop up previous guesswork, and yes, and there's absolutely no need for it. No need at all.
Well, the people using it don't really believe it, in my opinion. See, I used to do work on galaxy formation, and the idea was that neutrinos could be the dark matter, right? And in order to be the dark matter, they needed to have masses of about 14 electron volts. That was the favoured mass for an electron neutrino. So I was at a conference and I organised what I called a neutrino mass sweepstake. The intention of it was to raise money to take my girlfriend at the time around Italy. We were in northern Italy. So I did this neutrino mass sweepstake. Some professors there didn't like it, and then they thought it was a bit of fun, and they gave me some money. But the point was that what I said was, okay, I want you guys to say, in orders of magnitude, what you think the mass of a neutrino, the electron neutrino, will be when it's found. Is it like between 10 and 100 electron volts, 1 to 10, 1 to 10 to the minus 1, 10 to the minus 1 to 10 to the minus 2, and so on. And although they were all doing mathematics assuming it was about 14, all of them, or nearly all of them, put like 10 to the minus 1, 10 to the minus 2, 10 to the minus 3. So they didn't even believe that their own application of mathematical analysis was of any validity at all.
Yeah, so is it all...
But I did have a holiday afterwards.
Oh.
And I haven't paid out because there isn't a definite answer yet.
Oh yeah, I'm sure you're profitable for yourself there, Piers. Very good, yeah. So Eugene, do you reckon the Parker probe will help the electric universe model? Because obviously it's going to take, 7 years to get there.
But there isn't a single electric universe model, is there? There's a lot of good ideas.
No, that's right. No, there's core understandings, but yeah, I mean, we're still looking to see what version of the electric sun we have.
Yeah.
I mean, obviously Sapphire is testing the first model, which I think is Tony Peratt's model, I believe. I don't know.
So ask Eugene what the Parker probe might
yeah, so what do you reckon the Parker probe will find then, Eugene?
Do you mean Sapphire?
No, Parker probe, you know, NASA's...
I actually don't know. I'm kind of surprised that there wasn't much discussion about it in the EU community, because this is actually it's the probe that's going to get the closest to the sun. I think it's maybe 10 solar radii.
That's right, yeah, I think it's 8, or yes, but it's something like that. It's not really going to touch, is it? It's still going to be quite away from it, but it's certainly going to be a lot closer than anything else has got.
So, I think we can actually, of course, in the EU kind of agenda, one could expect some, so to speak, unexpected, electrical malfunctions or something like that. Aside from the regular problems.
I was talking to Harry, who's in the group, and we were talking about whether there will be electrical disruptions, and have they taken the real electrical output of the sun into consideration? Because we saw with Sapphire, with the tungsten tip, that it vaporised purely because of an electrical current, nothing to do with heat. Heat was generated, but it was the electrical current running up and down the tungsten tip that vaporised it. And I'm just thinking, you've got these little tiny probes sticking out from outside of the heat shield, and how long will they last?
We run a sweepstake, maybe.
Yeah, you could, that's a great one, yeah. The trouble is, you have to pay out though.
No.
It's going to be how long?
Yeah, we could maybe. We set it up, that'd be a bit of fun.
Well,
Piers what is the answer?
Man, obviously.
There's no declared answer.
So predictions about how long it will last.
Yeah, I know, but you're going to have to pay out because there will be a time. Yeah. Whereas the sweepstake on the mass, they're still measuring it.
Is it?
I'm learning.
Is it even going to be? I suggested it to NASA. I don't think they were impressed on one of the Facebook groups, but the fact it was out of date before it even left the launch pad because of Sapphire. I didn't get a response, or they didn't ban me from the site, which was good, which is they could have done.
Phil, can you explain for people what the aim of the project is?
What, Sapphire?
No, the probe, Parker probe.
Well, the probe is to try and...
And why is it called Parker? Because people here don't know.
Yeah, Parker is named after an astronomer, so like who done work on the sun. And, yeah, and he's...
Well, a solar physicist.
Yeah, that's
magnetic, expert on magnetism.
Yeah, and he's the only one who's still alive they've named a probe after. I think he's the only living person they've named a probe after in his honour. And yeah, so basically they're trying to work out why the corona is hotter on the outside and not near the surface. So
because
it's
the surface, the photosphere is 6,000 degrees, and the corona is like 1,000,000 degrees.
That's right.
Which is very strange.
From an electrical point of view, it's it is the anode. The sun is an anode. It releases charge to the virtual cathode at the heliospheric boundary, and it's the negative dragging the charge from the sun, and so it will naturally, as it gets nearer the cathode, accelerate. So, I mean, we know.
So the cathode is the
heliospheric boundary. Yeah, it's a virtual cathode.
But you've got to explain why one's an anode and one's a cathode.
Well, that's what Sapphire's hopefully doing. Is the fact that whether the sun is an anode or a cathode, it's electrical. Certainly, we can see magnetic fields, but we are working on the assumption, and that's, like I say, what the cathode's about, is that the anode is the sun. The sun is an anode discharging to a virtual cathode, which will basically pull the charge to it and accelerate it.
Yeah, no, but if you're saying that, you've got to have a source of... It's an electric current coming
out
of the sun. Well, something has to go into the sun.
No, what's coming in is the current from the galactic arms.
Okay, so you've got to put that somewhere into this.
Yeah, so we're talking about a Faraday motor or more specifically a Hummer polar motor, where the actual charge goes in at the edges of the disc. It doesn't come in at the axis like you would with a Faraday motor. It actually comes in at the edges of the disc and comes out of the axis. So that is what we normally think of as how stars are.
All right, well, you need a diagram of that. But anyway, sorry, I diverted because you were actually trying to ask something, weren't you? Where does this temperature come from?
The temperature
Or perhaps you do.
Yeah, what would you reckon? I think it's friction going through the sun's atmosphere, and as it gets faster, more friction is generated and the temperature
Not 1,000,000 degrees now.
What do you reckon there, Eugene?
About the corona?
Yeah, the temperature rise.
Well, for example, Robitaille thinks that it's actually just a poorly understood, mechanism, in the sense that why do we even say that there is such a high temperature in the first place? It's because of the higher ionization, right?
Right.
So it's assumed that this ionization is purely thermal in nature, and that is because that's why we think there's those tens of millions of degrees. But Robitaille thinks that the ionization might happen due to some weird chemistry, if you like. He supposes that the corona is filled with small particles of hydrogen, like small clusters of hydrogen atoms, which sort of ionize the other atoms, such as iron, carbon, and things like that. And that's why we have these higher ionization levels there. And so it's just not as hot as supposed, by the gaseous solar model. And I believe that EU can actually add something to it again. If you say that the sun is an anode, perhaps it's actually like electrochemistry, not just chemistry. So maybe there is some sort of weird electrochemical processes going on which ionize the stuff in the corona and gives us this appearance of higher temperatures, whereas in the real world, so to speak, there's only, again, like maybe 5,000 degrees or something like that. So it's just, is it there in the first place, the temperature? This is the important question, I believe.
I think that's a very good explanation.
Yeah.
I heard Robitaille speaking in Albuquerque 4 years ago.
Yeah.
But you've explained it better than he did then. I mean, maybe his ideas have developed a bit.
Well, we're all developing ideas, aren't we?
But I just want to say about the standard model, what they say is they got this concept of magnetic reconnection, which is somehow magnetic fields joining up and then releasing energy. Now, it's complete poppycock, even under standard physics of, you know, the energy density of a magnetic field is half mu b naught b squared, but b squared over 2 mu naught, etc. So, where magnetic fields are joining up, then there's going to be zero field because they're oppositely joining up, you see. So the whole idea of magnetic reconnection is twaddle, complete twaddle. But I've been to presentations where they're talking about it as if it just gives the answers, you know. They don't have any detailed explanation or any equation which will give you how much. I mean, it's a bit like long-range weather, a bit like forecasting climate by people who can't forecast 2 weeks ahead. They're telling us what it's going to be 50 years ahead.
Yeah, it's ludicrous.
Which will make money, maybe, or get a grant. Anyway, sorry, yes, I diverted there to something else. But Rubitov's model is a bit like an LED. You see, you've got lots of, look, that's computer screen is white, but it doesn't mean it's white hot in there.
No.
And you have LED torches, which are, what? You know, I remember first seeing it, I think, how come? What's going on here? You know? Because if it was a tungsten filament, it's got to be, well,
very warm.
It's got to be more than 5,000 degrees to give out white light, right? It's not a tungsten filament.
Yeah, but diodes are something else.
Yeah, I mean, the assumption in sort of classical model is that it's all to do with heat, you know, heat and just more and more heat, and of course that is clearly nonsense. So,
can I ask a question?
The sun is a big LED, maybe.
Can I ask a question? I thought it was established that the corona was 1 million degrees, give or take.
Well, no, it's not. It's our interpretation of temperature.
Can I ask you?
Yeah, go for it.
What's Eugene say about that? Yeah. What evidence is there of whatever temperature it is? Actual evidence. Are they just using spectral lines? What are they doing?
As far as I know, it's only the ionization levels, because there is actually
ion 16 and so on.
Corona actually shines almost the same as the photosphere itself. It has almost the same spectrum. There's a so-called K corona, where K is the German word kontinuierlich, which means a continuous spectrum. So the corona has this continuous spectrum at basically the same temperature as the photosphere. So this is another evidence that actually it's not as hot as, you know, it is supposed. And again, Robitov's model, it kind of fits together. So I would say that no, corona is not as hot, because the only evidence we have for such enormous temperatures is ionization, and ionization is much easier to achieve through basic, you know, electrical means rather than thermal processes.
Yeah, well, like a neon tube, you know. You don't. Well, it's that sort of stuff. Yeah.
Okay, well, I think we will now. Should we look at the electric model? We're talking about the Sapphire Project, Solar Atmospheric Function in Regulation Experiment. It stands for, and they were going to look at different sun models. This is the first one. It's only been online now a couple of years, giving us the data. Fantastic success. Even with the proof of concept model, we had output spikes of 10 million volts DC with only 1800 watts DC going in. Output spikes of 10 million watts. So a fantastic success. We've already got the transmutation of elements, which is fantastic.
Unprecedented.
Really fantastic. So already we are going a long way to actually proving that the stars are electric in nature. So this is from 2016, this video clip. It's the first 8 minutes or so of the Monty's live talk, his presentation at the conference in Arizona, in Phoenix. And yeah, this actually shows what the Sapphire Project is physically, the actual plasma engine. So we'll just watch this and then we'll have another little chat.
In 2013, the Sapphire Project was created. The objective was to replicate the Sun's atmosphere in a laboratory on Earth.
Wow. Look at that.
A lab was designed and built, and at its heart was the Sapphire plasma engine, the only one of its kind on the planet.
Michael, if you guys want to turn your microphone on at any time. Okay, we can see you and Colin. Can you see me in the background talking to you on the cell?
Today, 4 years later, the Sapphire team gives a tour of the lab via the web to a scientific review panel scattered all over North America. Two things define Sapphire: a unique premise and a remarkably powerful methodology. The premise driving the project is the idea that electricity plays an essential role in the functioning of the Sun's atmosphere. The methodology used to build and run the Sapphire Lab comes from the world of engineering and manufacturing. It is a statistical procedure that allows for incredibly precise control over the design and managing of experiments. This combination of premise and methodology has yielded remarkable, if not startling, results.
Comment that those last 2.58s are
This test, we have ongoing video feed plasma. So these cups that you see, these balls, are actually not sitting on the surface. They're actually sitting just off the surface.
In August of 2017, the Sapphire team presented its most recent discoveries at the Electric Universe Conference, Future Science.
Yeah, so the Sapphire Project. I mean, what a fantastic piece of experimental science. Privately funded and already given us such fantastic results. You know the men who run Sapphire, Eugene, Monty and Michael and that. Very nice people as well, aren't they, really?
Yeah, certainly. I really like talking to Michael Claridge.
Absolutely.
Yeah, I mean, whenever I'm around him, I just start fountaining ideas. You know, it's just we have certain personal chemistry, so to speak. So I really enjoy talking to him. Yeah,
he's great fun, Michael. He's such a nice bloke as well. Really, really pleasant, really lovely. Jenny, and they're open to ideas and and exploring thoughts and but based from a proper point of view though. I mean, from a real sort of like electric point of view, and what they're doing in Sapphire is absolutely astonishing, isn't it? Really.
Yeah, it's actually. I mean, if you look at what they did, actually, I mean, how complicated it is. It's just amazing. Yeah.
Yeah, 40,000 individual bits have gone into making that and designing it and building from the ground up. Something totally original, and to see it work is so encouraging.
Did the Sapphire?
Yeah, absolutely, I agree.
Does the Sapphire Project make any or have any opinion on what the Parker probe might come across?
No, they I haven't heard anything, but obviously we're all speculating that the Parker probe will basically back up an electric sun model. But I think it will happen a long time before it gets there.
Well, the temperature that they will find when they get into the corona will be, if we're correct, a lot lower than this 10 million degrees.
Yeah, so that is one thing we're really looking forward to, seeing how well their estimation is good with the ionisation process. So we're expecting it to be a lot lower. Do you reckon?
Yeah. It's logically it's going to be about $6,000.
Well, the same as the surface.
Yeah.
Do you reckon that, Eugene?
Well, I think that they wouldn't kind of measure like normal temperature, so to speak.
Right.
At best, they would measure what is called the plasma temperature, which is essentially a kinetic energy of electrons, basically. Okay. And we actually know that it is quite hot. It's quite big, this kinetic energy, and it corresponds to. In the solar wind in the vicinity of Earth is of the order of like hundreds of thousands of degrees. But of course, it doesn't mean that it's so hot there. It's just the kinetic energy of particles, which might be achieved through electric fields, for example, or something like that. Yeah. The solar wind itself has an electric field because it's moving magnetized matter, and so it's basically an alternating magnetic field of its own, which corresponds to the electric field just through Maxwell's equations. So who knows? But I would expect that they would be really surprised, in the sense that corona wouldn't behave as they thought it would be, because basically because of what we said before about this, possible role of chemistry and maybe electrochemistry. Maybe they would detect some actual currents flowing, because in many EU models it is thought that there is a Birkeland current running through the sun, from galaxy or whatever. So maybe in those areas where Parker probe would go, it could actually, catch this current, so to speak. So it would be really interesting. But again, I'm very concerned with the safety of the probe itself, because as you might guess, it's kind of approaching the sun really quickly, so it's kind of losing altitude, so to speak, very quickly, which again, in the electric terms, if we are to believe the EU models, means that it goes into the areas with other electric potential really quickly, which potentially might lead to, things like electric discharges and whatnot. So, yeah.
So there could be an electric discharge through the probe as it's falling, and then it'll just explode.
No, that's I need to know what the actual probe is made of, really. One of the big problems with them early probes to comets was the fact they made them in copper, and so they discharged. Whereas the probe that landed on comet P51, is it? Whatever it was.
67.
67. That's it. Yeah. That was made of a honeycomb, but they still had problems with electrics as expected. But it didn't discharge to the actual machine. So we really need to know what the probe is made of. I mean, how much copper does it have on board, and because I'm really not hoping, but we're expecting to see some sort of electrical
reaction. But we don't know how well they've guarded their electronics. So, yeah.
Probably not well enough. I think Eugene's point about temperature, so-called, is very important, because you see the concept of temperature applies to some gas or liquid essentially in equilibrium. It's a quasi-static thing. Yeah. Now, in the case of electrons moving very fast, that isn't the case at all. So actually, when you look at solar wind reports and measurements from NASA, they don't talk about temperature. They talk about energy of electrons and electron volts. And I think that is right. We should avoid the use of temperature. I can see there's going to be a temptation to translate these electron volts into some equivalent temperature, but you see, it's not a sensible concept, because these things are not they're not an equilibrium system.
Right. Okay.
And there are actually even in like mainstream plasma physics, there are mechanisms that might charge the probe and actually create a potential difference across the different parts of the probe. Because, for example, in the sort of a frontal area which is facing the sun, it should be positively charged. Because, first of all, the material of the spacecraft ionizes because of the sun. That's the first point. And there's also, solar wind protons hitting it from the forward part. And there's also a shadow, so to speak, of the solar wind, where protons cannot enter behind the probe, But electrons can, because electrons are smaller and lighter, so the back part of the spacecraft would be charged negatively, whereas the frontal part would be positively charged. And I believe that at such distances, the potential difference might be very big. I mean, I would expect something like kilovolts or something like that.
Well, maybe even bigger. Just over the length of the spacecraft, over the probe, yeah?
Yeah, across the spacecraft.
That's quite that's quite a difference, isn't it? That's quite a gradient between negative and positive.
Yeah, so I mean, if the surface of the probe is conductive, then maybe it's not a big issue, It would just constantly discharge itself through the spacecraft's outer shell, so to speak.
Like, yeah, if they built some sort of Faraday cage, then that would be okay around the electronics.
Yeah, basically that's what I'm saying. Yeah.
Okay. Well, we've come to that point in the evening where we give a little time over to Piers. Yes, here we go. Piers.
Well, have we got any more questions for Eugene, first of all?
Well, we're going to go back to that afterwards but we got to my timings 20 to 7. So you've got until 7 o'clock, and then we got the final half hour chat, and we want to hear what Eugene has to say about your little chat as well. And so, Piers, we kindly hand the floor over to you.
Okay, well, can you hear me from here? I don't know if Eugene can hear properly or not.
Yeah, I can hear.
Okay. Right, so this is largely based on what I said at the Weather Action meeting on Friday. And I gave a report on some things going on which are all quite interesting. Because right now there is a bit of a crisis in physics, as well as politics. First thing I would say is tell you about a coming up meeting. On the 14th of November, the Royal Meteorological Society and Imperial College are holding a sort of special meeting stroke conference, reporting on the IPCC's proposition that we're moving towards doom of an increase of temperature of 1.5 degrees C. And it's obviously, I think this is all poppycock, and the world has actually called it, and their model of everything is based on fraud. But that apart, it's turning out to be rather difficult to get into this meeting. If you go on the website, it says it's oversubscribed, which probably means that everybody in the Met Office has been told to go there, so it will be oversubscribed.
Pack it out.
But politically, it's extremely important, because the powers that be do need the the concept of man-made climate change to justify almost everything. You know, sustainability runs through the need to have Agenda 21 developments in towns, social cleansing of all sorts, increase in energy prices, massive ongoing profits for the oil companies because energy prices are maintained artificially to make it worth a farmer burning food instead of selling it to eat. So anyway, I'm rambling a bit there, but the point is that meeting is going to be very important, and it looks like we're going to have great difficulty getting in there. Usually at these meetings I go in, 2 or 3 of us, we stand near the front and put our hands up and they can't ignore us, and then we ask questions which they flounder to answer. And the question I want to ask is, well, could you name one scientific paper which shows that carbon dioxide real levels as measured or estimates of in the Earth lead to increasing temperatures? Now, there's no such paper in existence. So we put out a 6-point challenge to them that we've asked them to respond by the 1st of December to give evidence of such a scientific paper. And we're asking the United Nations, Al Gore and the BBC to come up with an answer. And we know they won't, but I wanted to put forward this at this meeting, which will be difficult, unless Peter Gill, who's another physicist, manages to get in there and ask it. Well, it might be the answer is we'll have to give out leaflets outside. The point is we're going to have to raise the political temperature of debate on this, because otherwise this thing is just going to be reported by the BBC as a new absolute truth and the reason why you've got to pay loads more electricity prices. Now, we've given them till December the 1st on this 6-point challenge, which is now in video form, to respond. And we're going to have a meeting on the 20th of December, and if you're in London, you come along. 20th of December in the Royal Institution, which was Michael Faraday's heritage. Now, Michael Faraday, as you know, was Sir Humphrey Davy's, the Davy lamp, assistant. So Humphrey Davy was an upper class guy. I mean, anyone who did physics then had to be upper class because there was only where they had the money, right? But Humphrey Davy was a working class guy who was his assistant, and then developed these. Sorry, Michael Faraday was the assistant of Humphrey Davy, and then developed electromagnetism. So it's not the same as the Royal Society. This place it believes in experiments a lot more, and every year they have this. They have an address where they do experiments and demonstrations for school kids. This isn't ours, but we're deliberately having a meeting there on the 20th of December where we're hoping to do some demonstrations to show that the CO2 climate model is poppycock on the lines of, as I explained, the Porto conference, and there's this on the video from there and also in my paper which you can get on weatheraction.com. So hoping on the 20th of December to have a demonstration model, you know, of a bit of CO2 in one bottle and air in another, and a warm surface, and show the CO2 bottle warms up quicker but also cools down quicker. So they're actually reaching the same temperature, and if they don't reach the same temperature in the long run, then of course it means that the CO2 model breaks first and second laws of thermodynamics. But that's what we're going to do there, we hope, and also have some empty chairs. 3 empty chairs, one for Al Gore, one for the BBC, and one for the United Nations IPCC, to let them answer.
Are you going to put their names on the chairs? So
we will. We'll put their names on the chairs. And hopefully this will be video. And if we do it right, we could get a viral, response to this question. You know.
Yeah.
Now, so far they've been very helpful in the Royal Institution, but I don't know if they realise what they're letting themselves in for. Because you see, the BBC's down the road and they'll put a ton of bricks onto them to stop this meeting, just like they did when we were booked into the University College. They closed down our conference there and we had to go to Conway Hall nearby, which is the,
That'd be nice to do in the Royal
So anyway,
Institution.
that's the score, but there's 2 things I'm asking for really here. One is people to help give out leaflets outside the Royal Met-Soc meeting, which I think is 1 o'clock on the 14th of November. And bear in mind you could run into trouble. And secondly, come along on the 20th of December, which will be great fun. Hopefully the meeting will happen as planned, and it's been booked in a proper manner by a vicar. Dr. Philip Foster.
Oh,
so,
Philip, yeah.
And, he knows what he's doing, and he knows all
Absolutely.
the pitfalls. So anyway, that's my basic news. Other news, yeah, might as well do them all at once if you don't mind. Right, Professor Richard Lindzen came to England recently, and he gave a presentation to the Global Warming Policy Foundation, which I unfortunately couldn't go to, and he was talking about the art and science divide. And he talked about a guy called Lord Snow, who talked about this years ago, whom I met years ago and wrote letters to years ago when I was a student. And Shahina's here, very interested in the art and science divide, and she's got some pictures, paintings, well, weather paintings, okay, so you can explain them later, but they're about bridging the gap, okay. But that's, the point about Richard Lindzen was, he was saying that really the political world has no comprehension at all of what is going on in science, so they're told complete lies, and they believe them, they just believe them. I mean, I saw Chris Williamson on TV recently. He's an MP, great supporter of my brother, and he was on Russia Today, and he was talking utter, complete, total bollocks. He said, oh yes, it's going to be 1.5 degrees centigrade is going up, and he started listing all this about crisis and this and crisis and that. It's complete right. There will be crises, but it's going to be caused by cooling, not heating.
Yeah, absolutely.
See, he understands completely zero, or else he knows it's rubbish and he's repeating a mantra, one or the other. I don't know.
Well, it's
either way, it's worrying.
Fraud, isn't
given,
it?
Well, it is complete fraud. But anyway, the point that Lindzen was making politically is that there's a big divide, and the British Parliament and most parliaments are full of people who understand nothing in science at all. In China, as a matter of interest, the political establishment is full of engineers who do have a better understanding of what's going on, which might be a reason why their economy is a lot better than ours, as a thought. Anyway, so that's Lindzen. The next thing was we had a meeting, another GWPF meeting, which is Global Warming Policy Foundation, by the way, where a woman called Zarkova spoke. Very interesting talk indeed. And she's done some analysis of the magnetic fields of the sun, right? Now, you know, with any data set, you can analyse it into harmonics, waves, i.e. Fourier analysis. Now, there's more advanced forms of Fourier analysis called principal component analysis, which is in 2 dimensions and so on. But she's done analysis of the positive field from the sun and the negative field from the sun, and says, look, just doing them as one thing doesn't work. You've got to do 2 analyses of positive and negative field. And she's done loads of stuff, and there's very standard packages. You can put data in here, and these things even come out with model equations which will explain the data, describe the data. Describe, not explain, describe. And in this she comes up with predictions of the back predictions of the Maunder minimum, or the Dalton minimum, and the Maunder minimum, the well, all sorts of stuff in the past which we know happened of low solar activity, and it predicts forward in time a minimum, which we predicted already in weather action, and she has it from 2028. The main bit is 2028 to 2030. We got it a bit earlier than we got, which is nice because we could live to be there. Although I'm told I'm going to live to be 108, so I'll be there anyway.
Who told you that?
A friend of mine.
Your new best friend.
Anyway, but this was really, she's not using any theory, she's just using some mathematical analysis, looking for analysing 2 components instead of silly physics like trying to put things into one thing. You see, a magnetic field like positive and negative, so she doesn't both. Because that's how the sun works. You have plus field and minus field. They flip over. Well, so she has the plus field going to the south and then minus field going to the north. And then they go round, and she's got these amazing graphs of. So the point of that is that really she's producing results which are actual predictions and back predictions based on observations and analysis, which are miles better than the Russians' attempts at dynamo physics. Now, I know people who are doing solar dynamo, and you know, it's sometimes Kirill there, Kirill Kuznetsov, he's worked with me. And he does really good stuff, but the guys in there are pretty narrow-minded, you know. You give them a proposition and say, no, it can't be done, you know what I mean? And they're really stuck in stuff. I mean, I remember asking them one thing, I said, Kirill, could you ask your mates, say, look, when the moon hits the magnetotail of the Earth, it's going to have an effect. And he said, no, I don't think so. And he went to his friends and said, no, it was no effect.
Of course it's got to.
Well, okay, they said, no, it can't have an effect. They just said, it can't. I said, do you mind having a look? Right. A month later, they came to him and said, oh, Piers, it does have an effect. Anyway, interestingly, it means that dynamo theory is, well, it's been superseded by observation. Whether they're going to develop a dynamo theory, I don't know, but you see, the Rubiton model and other people's models might not enable a dynamo. I don't know. That is a question for Eugene. What do you think about dynamo theories?
Yeah, what do you think about dynamo theory, Eugene?
So
do you know about it?
Yeah. I'll just leave it at that point, but just remember, 14th of November, offering help, please. 20th of December.
We'll go through these dates again.
Yeah. Okay.
So, Eugene, what do you think of the dynamo model? Do you see any relevance in it?
Well, as far as I know, this is basically the only model that exists to explain, you know, the magnetic fields of Earth and Sun. But I can say that I'm very happy with it. I mean, to have such, you know, consistent cycles of changing the poles on the Sun in particular. I mean, we haven't seen any, you know, polar reversals on Earth yet. I mean, in historic times. But on the Sun, we observe them every 11 years. It's kind of strange. I mean, such consistency. How this dynamo rearranges itself every 11 years. It doesn't look very compelling.
Well, I think we need to sort of establish the magnetic fields of other stars because, you know, if the solar system rearranged itself, then that might be something to do with it.
Well, I think, I'm very certain it's to do with the planets interacting and the fields that come out are to do with the planets. That doesn't explain the electrical connection, but they are involved in the solar cycle, other cycles, and a very interesting one she came up with was about the 2,100-year irradiance cycle, which she said was to do with, and I've heard this before, the Jupiter, you see, moves the centre of mass of the universe, of the solar system is in one place. When Jupiter's one side, the Sun will be the other side. So the Sun wobbles around the Barry centre, as it's called, and that means it gets like one solar diameter nearer to the Earth and further away in an oscillating manner. And the period of this, because of all the other planets, is a big period of 2,100 years, which does turn up. And she says then that this is to do the Sun slightly nearer, and that increases the effective brightness of the Sun by enough to make it feel warmer. Now, I don't think the figures will give you that because it's just a solar diameter in 93 million miles. Right? You double the proportion because it's an inverse square law, but I don't think you can get the increase you want. So you've got to have something else which uses this wobble. I don't know, but you see what I mean? That's her idea. But she just put that in as a passing thing. But the significance of what she's done is this, you know, intelligent analysis of magnetic field measurements. And thanks to NASA, we've got loads of data to do it on.
But we've got to look at, so we should look at other stars to see if their magnetic fields change at some point.
Well, my view is if other stars have got changing periodical magnetic fields, they've got planets around them running the show. So that's a way of finding planets.
Do you think that, Eugene, the fact it's planets that's altering the magnetic field of the Sun?
Well, not exactly like, we don't know about altering it, but they're doing something which is a complex thing we don't understand.
Eugene?
Well, it's a plausible model, but somehow I think it's you know, relying on very weak forces. I mean, there's basically tidal forces. Well, not exactly tidal forces, but get the idea. It's basically the change of, again, as you said, barycenter position and so on. Maybe it's actually driven by electromagnetism. I mean, those cycles. Maybe it has something to do with, cosmic ray flux or something like that. Because, cosmic rays, not only they fall onto the Earth, but also onto the Sun itself, because, where it has the coronal holes, which are basically like highways for charged particles, right? So maybe it has something to do with that, or some other type of influence from the side of galaxy, or...
So that's what I was wondering, is it an input, is the input?
Yeah, I'm more or less kind of talking about that, but in very vague terms, because I don't really know how it works, and I don't think anyone knows at this point.
No, certainly.
Well, I'm not saying I know. I'm just saying I got some ideas. The point about galactic cosmic rays, though, is that they're 1/300th of the energy flux of particles from the sun, anyway. So they're not going to have a big role. They're used by all sorts of people as a, hocus pocus, let's try it, but I don't think it works. Because the sun has got an 11-year cycle, which modifies cosmic rays into an 11-year cycle. However, when it comes to the world temperature, the main cycle is 22-year cycle, which is about magnetic connections with the sun, not about the cosmic rays coming in, which would have to give an 11-year cycle. Now, so the same argument about their unimportance would apply to the sun itself if they're hitting the sun. And anyway, they come to the sun isotropically. So
yeah, I actually saw a recent paper. I know about this research of Zharkova. It first appeared in 2015, I believe, something like that. So I read these papers, But I actually saw a recent paper of 2018 by Ilya Usoskin. Maybe you've heard about him. He's working in University of Oulu in Finland. This paper basically re-evaluates the significance of solar cycles in terms of energy flux from the sun.
Oh, okay.
Because when there's a high solar activity, there's lots of sunspots. And thus, there's also lots of what is called faculae around the sunspots, which have higher brightness, essentially. So although the sunspots themselves are dimmer because they have lower temperature, these faculae are much brighter than the regular solar photosphere, essentially. And that's why at high solar activity, we have higher energy flux from the sun, even though, again, sunspots are dimmer.
Good point.
This recent paper reevaluates the significance of this change in energy flux. And I believe they say that previous estimates were very, very low to what they have acquired now. And as far as I remember, they were talking about like 4 to 6 watts per meter squared difference. For example, if we compare the Maunder minimum with modern maximum, so there's like almost, maybe 6 watts or something like that per meter squared. Which is, of course, it's not like 1,000 watts, but it might be enough, to create these changes in temperature of the order of a couple of degrees.
No, that makes a lot of sense.
Yeah. So I would say that if the solar activity is the driver, then maybe not only the change in cosmic ray flux due to Forbush decreases, changes in cloud cover caused by the change in cosmic ray flux, but also the direct input of the energy from the sun also changes because of that. So that this is another factor that might play a big role here.
Well, that's a nice natural break. We're going to have a few announcements, then we'll go back for the last bit of chat. And
just before we do that, about what you just said, very interesting. We should study that paper you just mentioned. We could have a presentation on it about recent finding the stuff.
Yeah, I can send it to you.
Yeah, stick it in the Facebook. Yeah, put the link in the Facebook group.
Okay. And the next thing is about the role of cosmic rays again. I did some close analysis to see what happens when you have activity on the sun and weather changes. And what you get, and I've analysed it, well, one particular time I looked at it, you get an increase in solar activity, and more or less at the same time, increase in geomagnetic activity, which means there's a very tight connection, or the geomagnetic activity might be from the rate of change of solar activity. But anyway, they pretty well come together, and the weather effects come together with them. So you get formation of tropical storms in our R5 and R4 periods, which are directly related to things happening on the sun, which maybe you have a coronal hole, then a day later you have this, or 2 days later you have our geomagnetic activity, and you get an acceleration of formation of tropical storms, for example. Then after that you get a decrease in cosmic rays because of the extra magnetism. So you see the cosmic ray effect comes after the weather effect. So the idea that the cosmic rays are the mechanism of linkage is completely out the window. It's nonsense. It happens later. They're just like a thing that's happening at the same time.
It's a bit like CO2 and heat getting around the wrong way.
It is. It's a bit like if you didn't know anything and you lived in a glass bubble like a politician and looked out of the window and you saw trees moving around, then you, oh my God, and the window's shaking, then you say, oh, the trees are causing the wind. Obviously, there's the evidence. You see the trees move and then you get hit by wind. So, you know, I mean, the point is, if you don't understand cause and effect, you will believe anything.
You can do. You can do, yeah, absolutely.
So my research shows, and it's pretty simple stuff, that the cosmic rays are just a side issue.
Oh. Thank you, Piers.
Even though they might change people's biology and because they cause chromosome damage and so on. So but that's something else about evolution, which happens quicker when there's cosmic rays around. But it's not because they're efficient or not at connecting the sun and the Earth.
Well, announcements. What we're trying to do with these little evenings. Oh, and first of all, Sharon came up with the idea that we should have outings, which I think is a great idea, to Science Museum and various other places of interest, which will be of particular interest to us. The Science Museum at the moment has 2001 in 70mm remastered, so that might be one we might want to think about. Go and see 2001: A Space Odyssey, just for a bit of fun.
Wow, I've seen it 5 times.
Well, I've seen it once on the big screen. So, and there was something else coming up. Sharon, there was something else coming up as well. You suggested the Science Museum. Some other.
Yeah, they're having an exhibition and it's about the sun. Yeah. At the moment, it's on until February 2019.
So we've got a little while.
Yeah, so we've got a little while. But I mean, while we know it's going to be a huge laugh for us, I think it might still be good to get together and
No, I think we should.
Because it's going to have a hot photosphere stuff in it, presumably.
Well, yeah, it's going to have a lot.
And so I think these are the sort of things we've got to get down and get to and be very pleasant and informed and involved.
Are you going to give us an outing? Which would be a bus, like we take the drive us.
Nothing like that. I think it's more likely we could all organise ourselves to actually
get your oysters out and
and hang out,
to the station.
Go in the cafe.
Yeah, so this is what we're going to be doing for the new year. We're going to have outings, have a bit of fun. Have the fun ones as well as the more serious ones, like Piers has invited us to. What are those dates again, Piers?
The 14th of November, it's in the Conference Centre, 1 Victoria Street. But we'll put out some information. Those who want to come, meet beforehand. Look, go onto the website, Royal Met Sot, and try and log in. But it says now it's full. But you know, give information to demand a ticket. But my guess is they're going to keep it full, and they don't want anybody like us turning up.
No,
we'll have to go along with leaflets and be ready for trouble, right?
Placards,
you know. Yeah, no, seriously, we could. See, we've got to make an impact there.
Yeah.
Otherwise, we need a TV station to help us. The trouble is that Russia Today now propagates man-made climate change, even though George Galloway agrees with me. I don't know if he's going to
that's
now
it.
agree.
Well, obviously we can stick stuff out for the.
But we've got to get media there somehow.
Yeah.
Someone could chain themselves to the railing.
Right, any volunteers? John.
Ladies chain themselves to the railing.
I'll give out leaflets.
Oh, actually, might be able to get thingy, Jess down. She might do that. She's in animal rights and all that. So
animal rights, yeah, but those are mad greenies that believe that
but
the planet
she's going to do that sort of thing, chain herself to ladies.
You should do it for any cause either side.
Well, I mean, she certainly has an interest in the environment and and what we're up to. She's a member of the group, so.
All right. Well, that's the 40th of November. 20th of December, that's again as an afternoon thing. They're both afternoon things.
Okay.
At the Royal Institution.
Are these Saturdays? Are these Saturdays, do you
No,
know?
the 14th of November is a Wednesday.
Okay.
The 20th of December is a Thursday, I believe. Is it a Thursday?
Yeah. Well done.
Okay.
Well done over there.
There's a man on the ball there. You can tell he works in the school.
Yeah, absolutely. Well, I think at this point we almost about next month. What we're going to be doing next month. Next month, I'm giving the floor over to my partner over there, Rob, and he is going to be talking and getting together with our friend over here, Piers, and I'm going to be basically leaving it up to Rob to sort out. So. Do you want to give some idea of what's going to be happening next month?
If you like, I mean, I've mentioned it before. Hello, Facebook. So the idea is we're asking Jeremy Dunning-Davies, who's lecturer of physics at Hull, to elaborate on a prediction he made during the Electric Universe conference that Phil and I attended in July. He predicted the death of Professor Stephen Hawking would have an effect on research in the area of black holes. His prediction was essentially, now that Hawking has passed, there'd be more room for original thinking in that area. Jeremy, I think in the 1980s, wrote a paper that was critical of Hawking, and it pretty much ruined his career, or not ruined, it negatively impacted his career in a significant way. He spoke very mildly at the conference about that and how the opportunity was now there following Hawking's death to maybe push the science on a little. So we're asking him to talk about that because that's current. That's a prediction he made in July that's been actually borne out by the facts subsequently. And we'll be using that as a theme. I mean, I'm very excited about Piers's event at the Royal Institution on the 20th. That to me, if you haven't seen some of the Royal Institute Christmas lectures, the Faraday lectures, you should definitely seek them out. Especially, I'd say, the talks by Eric Laithwaite, I know Piers knew. For me, were formative experiences as a child. Seeing a frail man being able to pick a 40-pound weight up above his head because it was spinning really, really engaged my curiosity to an extent that I've never quite got over. But the hope is that on Tuesday I'm meeting Professor Frank James for the Royal Institute.
I'm going to do anyway.
We're going to and we're going to ask Professor James if he'd be willing to present something about how Faraday, as I mentioned earlier, came across what I'd roughly call the forces of scientific conservatism. He had a non-Newtonian model for how electromagnetism worked.
This is a professor of history of science, you should explain.
So Professor Frank James is the professor of history of science and a Faraday expert, and he's based at the Royal Institution. The aspiration would be for him to relate to us the experience Faraday had trying to push through a new paradigm, the electromagnetic paradigm. Failing his availability to attend, I'm going to relay his knowledge of Faraday. He's written several books on Faraday. I've managed to read one so far. Very interesting, and again a paradigm shift. So the broad theme for next time is going to be individuals who have brought about a scientific paradigm shift and the resistance that they'd encountered. That is the plan for next time. I'm really excited about going to the Science Museum with Sharon. I think we'll definitely do a little weblog, vlog, whatever you call it, video log
Hopefully she'll bring the Zoom with her.
Well, yeah.
We could do one of these meet-up groups.
Yeah. No, I'm also. I think we should, in the run up to Christmas, run some kind of, I don't want to call book. We get William Hill involved and run some kind of. We could have fun just predicting quite how far the Parker probe will get.
Before it blows up.
Yeah, I don't know. That sounds like fun.
Well, I do know this head of the former head of the Special Bets Department at William Hill.
I bet you do.
I'm sure because he was in charge of the weather betting.
Sure.
Well, they'll entertain anything as long as they can make money somehow.
Yeah.
I mean, you can bet on, the Martians landing if you want to.
Yeah, and Elvis coming back. Yeah,
absolutely.
So
no, take your money.
They just receive money daily. But
that's more likely in the program.
I don't know if it's measurable and reportable that they would entertain that.
Yeah, I just think it maybe be we could put £10 down. And
what might the Parker probe fund? It's got to be very well defined. Right?
Well, at what point will it
can't
fail? That should be the question. At what point should it fail? Anyway, going on from the Parker probe, I just want to bring to people's attention the fact that we've got the first of the conference videos out from the Electric Universe UK at electricuniverse.uk.eu videos, and for the princely sum of £12.99, you get access to every single talk would come out of Bath. We haven't done the Quantox one yet, but Electric Universe UK, we have the first lot of videos. You'll actually even see Pierce chatting.
You will see.
And you'll also see Jeremy Dunning-Davis, who I think is after your one.
Have they got the discussion as well that we had in the interview?
I don't know. I haven't actually got them aside yet.
Because there, you see, I made a mistake. I told people that I knew Professor Lathwaite,
right,
which I did. But then I said that he supported me getting a first, right? But that was Professor Latham. That was in physics, and Lathwaite was in electrical engineering.
Yeah.
I knew them both, but
slip of the tongue.
When I was reporting this, I got them muddled up, and I don't want to cause embarrassment to relatives.
Okay. Well, you've put it straight now, so I think.
Right, but if it's on the
several people are resting in peace as a result.
Well, I don't know.
Well, Eugene, we've got a quarter of an hour left. We're running well to time, absolutely brilliant. Any last thoughts as to where the Electric Universe paradigm is going to go, and how you see the future going from here?
Well, what I really like about the recent developments in the community is that, well, first of all, there are many new people coming up, and that this is great, and I really enjoy what you're doing here in the UK. But the other important addition to the whole EU thing recently was the experiments. Again, we were talking about Sapphire, but I should note that there are lots of enthusiasts doing, kind of garage laboratory kind of experiments. Especially when it comes to electric geology and things like that.
You're talking about Jacob's work.
Yes, exactly. People like Jacob Gable, and I really think that this is again the empiricism that you were talking about in the beginning of our panel. This is really sort of a revival of this initial curiosity that sort of old style science, and it's really cool that we're seeing it, and possibly it can solve, potentially it can solve some problems that we have even in astrophysics, and again, speaking about reconnection, we haven't actually observed magnetic reconnection in the lab.
No, that's right.
You only have theories that it exists, but
they're not even theories, they're hypotheses. I mean, there's no evidence at all. You can't even say they're a theory, really, can you? I mean,
Yeah. Well, anyway, I really like the things that are going on right now in the community, and I hope it would only gain momentum in the coming years. And again, it's great that more and more events happen like this very event that we're participating in now.
Thank you.
So thank you.
No, thank you.
Well, thank you for enjoying it. Brilliant. Now, I just want to touch on where we're hoping to take this. Rob wants to say one thing.
Just really quickly again, I'm really excited. We have opportunities in London to do things that maybe in other places you don't. I want to reiterate Piers' idea of doing an alternative Christmas lecture in the tradition of Faraday at the Royal Institution is something I hope anyone who is able can find a way of contributing or being involved with, because this is tapping into the history of electromagnetism, and really what we can do here in London is something unique to the sort of density of the history of this place. So from my point of view, I wanted just to reiterate, when Piers told me he was doing that, I felt like a kid whose Christmas had come early.
Oh, wonderful.
And please, 20th of December, Royal Institution is going to be
we'll
amazing.
Advertise it. It's on. Well, it's going to be on Eventbrite. It might be on a provisional of Eventbrite, but we will put it on there.
Yeah.
We're not sure if we're going to have to ask for money for people to go or not, but you know, there is money involved in doing that.
Yeah. These events.
And we've got a lecture theatre of 100, so.
Well, let's pack it out.
Well, we should be able to do that, because when we've had them in Parliament, we've reached about 70, I think. I think we could, you know, for this type, for the way we're promoting this, I think we could.
Eugene, if you have any Belarusian friends who are coming to London for Christmas, please pass the message on.
Yeah, and we'll get down.
Thank you.
You're from Belarus.
Thank you, guys.
Thank you. I'd just like to sort of just touch on what we plan for the future. We've obviously trying to make it an educational event and take it on from there. But Piers saying that some friends are taking this further, and we are talking about an academy. So I'd like Piers to just briefly outline what that is.
Well, we set up a committee for the formation of the Accountable Science Academy, and the idea is that this event on the 20th of December will be the first public showing of this.
Okay.
But it won't be just that thing acting alone. It will be sponsored by Electric Universe UK and the International Geoethics setup run by Niels Axel Moore and so on. So, but the point we're making is that the way universities and so on are organised now is they basically suppress new ideas. And they are machines for the propagation of existing paradigms and the mutual reinforcement of them. I mean, if you go to the Royal Society, they all pat each other on the back, even though they might well think that guy's talking cobblers, but they won't say it, because if they do, that guy might say that they're talking cobblers. So, you know, it's an old pals network of non-advancement of science. We want to set up a different way of doing it, which will be completely open peer review. Peer review will be done in public. It will be done by people who are qualified, but their discussions will be in public, and what is said will be in public, and they publish or not according to, you know,
the feedback we get. But it's all open. It'll be all open. You know,
as an example, and we'd have more meetings of new ideas.
Yeah, because we're trying to push stuff in the UK. We're trying to get the real science actually working. Because as an academy, well, we want to go into the practical side. We've got lots of plans, but obviously we're on our own. We're doing stuff on our own, and we're going along at the steps we can do. But this is what we're pushing for. And
we'll have a series of meetings, which will be like, you know,
absolutely
alternative stuff or critical stuff, but you know, or even just people explaining what things are about. Now, in Imperial College about 3 years ago, I said to the head of research, I said, what you need here, if you want to advance Imperial ahead of the rest, I said, you need to have a professor of heresy who's going to come forward with all the alternative mad ideas, and you're going to try them out. And he looked at me as if, fuck me, that's true. But he said, yeah, and he sort of then didn't comment. Then I said, look, if you denounce the climate change theory, you'll be ahead of the rest, and you'll get the best scientists, students around the world will come to Imperial.
Yeah.
And then you will be ahead of the game. And he looked at me, and I could see he knew that this would work.
Yeah.
Could work.
Yeah, it could work.
Could work.
Yeah.
But then he said, Piers, Imperial is always ahead of the game.
Prove it.
Meaning
is
the
thinking
game
about it.
is money.
Okay.
And they know where the money is coming from. So this meeting on the 20th of December is the Imperial connection, is the lying fraud machine, the Grantham Institute, which is also an Imperial College, which completely contradicts the basis of Imperial College being objective science.
It sounds like a good place for a meeting for us all to get going. Bob.
Just really quickly, I can't help but feel that the Academy of Accountable Science, as well as being a brilliant idea, has got financial potential. If you're familiar with the work of Rupert Sheldrake, he's spoken many times about what he calls, I think, an Institute for Venture Science, essentially taking
oh yes, he has,
quote unquote mad ideas or innovative ideas and putting them forward to be
sort of test.
Yeah. Again, one of the things about being in London is there is an awful lot of money flowing through this place every day. We're hoping, I'm certainly intending to, going forward once we get this going, to find venture capital, because there are ideas out there within the community even now that are significantly superior, significantly more advanced than the current practices. So we can aspire to do really draw several straws together. I don't want to say strings together because that's the fascist thing. We're not like that. But we'll bring these elements together and hopefully form some kind of, to use a modern word, synergies.
Yeah, so Eugene,
okay, Captain, you like the sound of that? Us starting our own academy of real science?
Yeah, I've heard about this Institute for Venture Science. I believe Gerald Pollack is the director.
That's right, he is.
Yeah.
Pollux, yeah. Obviously we're going to try and start our own here in London, and we look forward to you lecturing in the future.
Okay, that sounds great.
That's a good idea.
Well, we've got 5 minutes. Is there anything anyone would like to add in the last 5 minutes? Pierce has always got something to add.
Well, yeah, but people haven't said anything will start off by saying something. Shahina could show us her pictures afterwards, or whatever. or even now, but other people,
I can tell you a bit about why I'm here.
Yeah, please do. Why not? Absolutely, this is an open discussion.
Yeah, so basically Piers drew upon some of the ways I'm trying to bring together some of the theories around weather in a more practical way. So I do something fairly basic. I look at what the weather conditions are, and I do what I call a reverse Jackson Pollock. So that means allowing...
You take paint off the canvas?
Well, kind of. What the weather does. The weather takes the paint off. So I use quite diluted paint, so it's more inconsistency to ink.
Okay.
I figure out where the winds are, and when there's a powerful wind day, I mean, you guys probably have a more technical term than powerful wind, but to me it's powerful wind.
Windy day.
Yeah.
That's technical.
I use a series of different materials and study their chemical compounds, so it's not just paint. And I put them out, and what I'm seeing is that actually you would think you would get like completely random images that make no sense to the eye. However, when you zoom into them, you see very distinct form.
Okay.
And I'm in the process of trying to...
After the weathering?
Yes, after weathering. So there's been crazy things during the weathering. So sometimes, for example, when it's been pre-storm day, you will see a canvas that has been weathered by rain, but the wind has stopped the other side of it actually, so the box closes on its own, things like this. There's just a lot of things that I'm seeing in a very physical way, visually, the impact of the weather.
Oh, okay.
And do you have anything you could share to the Facebook group just so we can have a look?
Yeah, if you'd like to go on my website, I haven't explained.
Well, yeah, okay. Well, we can post this. We've only got a couple of minutes.
Yeah, no,
now.
but
we can post
Well,
this.
that picture you showed me just now.
Yes, I can show you a picture.
As an example.
Yes, so
You've got a photo of the painting.
You know what? This sounds like an exhibition.
We're open to all sort of ideas of what we can get up to.
When I look at these paintings, well, if someone's trying to do abstract art, they wouldn't be able to get this complexity. So she's using nature to sort of drive in complexity. You know what I mean?
So that's so you'll see different results by.
I mean, if that was done by Van Gogh, I dare say people would say,
we
wow,
we can put it up on the Facebook group, Eugene, so you can have a look at it later.
Okay.
I don't know if you can see.
Step into the light.
Step into the light, indeed.
Yeah,
because this is the place for it. I'm sure that's why.
You see that?
Wow.
So
That's the environment getting involved with your arts.
And that's just ink you've left on a. I mean, I'm simplifying, but that's ink
I
you've left.
because I don't want to interrupt the process as an artist.
Right.
So this one I've just literally painted in the dark.
Yeah. Oh, okay.
So yeah, you do have you
and then put it in the weather.
Put it in there, and then dependent on the weathering. So I did, and also there's a lot of water theory I use, which is more complicated than that. But like for example, I will use one with rainwater versus normal water, and you actually see the difference that rainwater makes in comparison to normal.
Sounds like an exhibition and a mini lecture.
You see, water out of the tap is full of chlorine.
Yeah, absolutely.
And water from the rain has got no chlorine.
It's
all
chemtrails, but that's another story. Well, we've now come to basically to the end of our little session for November. We'd like to thank you all for joining us out in Webland, and I'll obviously be talking to you in the group via text and the posts over the next month or so, but we look forward to you coming back next month where Rob will be hosting.
And what was the date? Give us the date.
And I'll be able to do a lot more chatting on Facebook.
4th of December. Come back.
Yeah, 4th of December or 2nd? 4th was the 2nd. Yeah. Anyway, the first Sunday. Hang on. The first Sunday, and I think it is the 2nd, isn't it?
It is the 2nd.
It is the 2nd.
Not the 4th, it's the 2nd.
The 2nd of December.
So there we'll have a preview of what's going to happen on the 20th.
Yeah. Well, as we get along,
what's happened on the 14th of November.
We get more and more sorted out on how we're structuring these events and what the information we're giving. But for now, thank you for joining us, and we'll
thank
you, Eugene.
Thank you, Eugene.
See you later, people.
All right, bye.
Okay, Eugene. Thank you, son.
Can he see us?